Hello students, welcome to the in-depth learning classes. I wish you a very happy Independence Day in advance. Students, in this tutorial we are learning rational numbers. In last parts, in the first part, we have learned introduction to the number systems, different types of number systems such as natural number, whole number, integer, rational number, irrational number and so on. We have also learned rational numbers and their importance in our day-to-day life. In our second tutorial, we have learned the introduction to the number lines, what are the different types of number lines, how to plot number systems, different number systems on number line such as natural number, whole number, integers and rational number on number lines. Then we have started properties of the rational numbers. The first property which we have discussed was closure property. In this part, the third tutorial, we will see the other properties of the rational numbers and the important terms. Students, if you have not seen my previous parts, I highly recommend you to go and see my previous parts, which will give you the in-depth understanding of this chapter. The link of those parts will be given in the description below. Let us start with the properties, the other properties of the rational numbers. Like in previous class, we have learned the closure properties and we have found out that rational number follow the closure property for addition, subtraction, multiplication and division. In division, there is one condition that the denominator should not be 0. The next property is commutative property. The commutative property, let us analyze what do you mean by commutative. The commutative, if you understand, the word commutative comes from the word commutate, which means exchange or substitute. So in commutative property, we will take two number systems, two numbers from any number systems, and we will perform operation addition, subtraction, multiplication and division, and then we will exchange their position and perform the same operation. If the answer comes same, then we will say that that number system follow the commutative property. You will understand better with example. Let us take two natural numbers now. For example, 2 and 4. 2 and 4 are natural numbers. So let us perform first addition. So when we perform addition, which will be 2 plus 4, it gives us 6. Now let us exchange their position. A should come in the place of B and B should come in the place of A. So now 4 plus 2, the same operation addition, gives me again 6. So yes, natural numbers, even though they exchange their position, while addition they give the same results. Hence they follow the commutative property. Hence natural number follow the commutative property for addition. Let us do it for subtraction. 2 minus 4 will give me minus 2, while 4 minus 2 will give me 2. So you can clearly see the results are different. Hence, if I commutate two natural numbers while subtraction, it won't give me the same result. So hence natural number does not follow the commutative property for subtraction. Let us do multiplication now. So 2 into 4 is 8. Similarly 4 into 2 is also 8. Hence it follows commutative property. Division now. So 2 divided by 4 is 1 by 2, while 4 divided by 2 is just 2. So we can clearly see the results are different. Hence natural number does not follow the commutative property while division. Now let us check whole numbers. Let us take any two whole numbers. We know that in whole numbers compared to the natural numbers, there is only one additional number which is 0. So let us take one number as 0, another number as any positive number which is 7. Now we will see one by one whether they will follow the commutative property for addition, subtraction, multiplication and division. So let us add 0 and 7. So 0 plus 7 gives me 7. Now exchange the position. 7 plus 0 gives me again 7. So hence we can say that whole numbers follow the commutative property for addition. Let us perform subtraction now. So 0 minus 7 gives me minus 7. After exchanging the position, 7 minus 0 gives me 7. So we can clearly see the results are different. Hence, whole number does not follow the commutative property for subtraction. Let us perform multiplication now. So 0 into 7 is 0, while 7 into 0 is also 0. Hence, the results are same. So whole number follow commutative property for multiplication. Let us perform division now. So 0 divided by 7. So 0 by 7 is 0, while 7 divided by 0 is indefinite. So it's undefined. So hence we can see that they are not the same. The result is not the same. Hence, while division, it does not follow the closure property. Commutative property. Let us check integers now. Let us take any two integers such as minus 3 and 4. Now we will perform all operation one by one. So first addition. So minus 3 plus 4 gives me plus 1, while 4 plus minus 3 gives me again plus 1. So we see that the results are same. Hence, integers follow the commutative property for addition. Now for subtraction, minus 3 minus 4 gives me minus 7, while 4 minus 3 gives me plus 7. We can see that the results are different. Hence, integers does not follow the commutative property for subtraction. For multiplication, minus 3 into 4 gives me minus 12, while 4 into minus 3 gives me minus 12. We can clearly see the results are same. Hence, the integers follow the commutative property for multiplication. Let us perform division now. So minus 3 divided by 4 is equal to minus 3 by 4, while 4 divided by minus 3 gives me minus 4 by 3. We can see the results are different. Hence, integers does not follow the commutative property for division. Now let us check rational numbers. Let us assume any two rational number such as 1 by 2 and 3 by 4. We can take any rational numbers. So let us perform the operation one by one. First addition. So 1 by 2 plus 3 by 4 gives me 4 is the LCM, and I get 2 plus 3, which is 5 by 4. Now exchanging the position, so 3 by 4 plus 1 by 2 gives me the same, 4 as LCM and 3 plus 2, so which is 5 by 4. So hence I can say that for addition, rational number follow the commutative property. For subtraction, 1 by 2 minus 3 by 4 gives me 2 minus 3, which is minus 1 by 4. Now exchanging the position, so 3 by 4 minus 1 by 2 gives me 3 minus 2 by 4, which is 1 by 4. So we can clearly see that it does not follow the commutative property for subtraction. Now multiplication. So 1 by 2 into 3 by 4 gives me 3 by 8, while 3 by 4 into 1 by 2 gives me again 3 by 8. So we can see that yes, the result is same, hence it follows the commutative property. The last operation, division. So 1 by 2 divide by 3 by 4 gives me 1 by 2 into 4 by 3, which is 2 by 3. Now exchanging the position, 3 by 4 divide by 1 by 2 gives me 3 by 4 into 2 by 1, which is 3 by 2. So I can clearly see the results are different, hence it does not follow the commutative property. So I hope students now you have the in-depth understanding of commutative property. Let us go to the next property. The next property is associative property. The term associative comes from the word associate. So in this property, we'll associate the words in different order and we'll check if the results comes the same. If the result is same, then we'll say that that number systems follow the associative property. So as you see mathematically, it can be represented this way. So A, B and C are any numbers from any of the system. So on LHS you see that B and C are associated first and the result will be added to A. On RHS, A and B are associated and then the result of this bracket will add it to the C. And then we have to check for different operation as well. So let us see one by one. Let us assume the natural numbers as 2, 3 and 5. The whole number as 0, 2 and 7. The integers as -1, 2, 4. The rational number as 1 by 2, 1 by 3 and 1 by 5. I have assumed the number randomly. Now let us check one by one if they follow the associative property. Since there is a lack of space here, we will do it on the next page. So natural numbers, we have assumed 2, 3 and 5. So first for addition, let us check 2 plus 3 plus 5 should be equal to 2 plus 3 plus 5. So 3 plus 5 is 8. On RHS 2 plus 3 you have 5 plus 5. So 2 plus 8 we know it's 10 and 5 plus 5 is 10. So you see that after changing the association the result is same, hence the natural number follow associative property for addition. Let's do subtraction now. So 2 minus 3 minus 5 should be equal to 2 minus 3 minus 5. So 2 minus 3 minus 5 is minus 2 and 2 minus 3 is minus 1 and minus 5. So 2 minus of minus 2 is 2 plus 2 and minus 1 minus 5. So LHS you will have 4 and RHS you have minus 6. Minus 1 minus 5 is minus 6. And you see that they are not equal, hence it does not follow the associative property. The natural number for subtraction does not follow the associative property. Let us do multiplication now. So 2 into 3 into 5 should be equal to 2 into 3 whole into 5. 2 into 3 into 5 is 15, should be equal to 2 into 3, which is 6, and 6 into 5. So 2 into 15 is 30, and 6 into 5 is also 30. So this holds true, hence we can say that natural number follow associative property for multiplication. Let's do the final operation, division. So 2 divided by 3 divided by 5 should be equal to 2 divided by 3 whole into 5, whole divided by 5. So 2 divided by 5, I can write 2 divided by 3 by 5 should be equal to 2 by 3 divided by 5. This division, if I convert them into multiplication, so it will come 2 into 5 by 3 should be equal to 2 by 3 into 1 by 5. So LHS I get 10 by 3 and RHS I get 2 by 15. Clearly they are not equal, hence it does not follow the closure associative property. So natural number does not follow the associative property for division as well as for subtraction. It follows the associative property for addition and multiplication. Let's check now whole numbers. Since we have assumed whole number as 0 to 7, 0, 2 and 7. So let's do addition first. So 0 plus 2 plus 7 should be equal to 0 plus 2 plus 7. And if you simplify this, students, you can clearly see the answer will be 0 plus 9 is equal to 2 plus 7, and 9 should be equal to 9, and it's correct. It holds true. So whole number follow the associative property for addition. Let's do multiplication now quickly. So 0 minus 2 minus 7 should be equal to 0 minus 2 minus 7. If you see here, 0 minus 2 minus 7 is minus 5, should be equal to 0 minus 2 is minus 2 and minus 7. Now if you simplify the LHS, you will get plus 5, and RHS you will get minus 9, and clearly they are not equal, hence it does not follow the associative property. The whole number does not follow the associative property for subtraction. Let's do multiplication now. So 0 into 2 into 7 should be equal to 0 into 2 into 7. So 0 into 14 should be equal to 0 into 7. And if you see that 0 into 14 is 0 and 0 into 7 is also 0, hence we can say that whole number follow the associative property for multiplication. You can check with various other numbers and you will always find that multiplication is always associative. Let's do division now. Since we have assumed 0, so it will be a little tricky, but let's see. 0 divided by 2 divided by 7 should be equal to 0 divided by 2 divided by 7. So 0 divided by 2 by 7 should be equal to 0 divided by 7. Since I see that 0 divided by anything is also 0, so you will say that 0 should be equal to 0, but this is only one case in which you have 0, so the answer will hold true. But if you take any other number, for example, let's take another number as 1 divided by 2 divided by 7, then it will not work. So 1 divided by 2 divided by 7, if you see that, this will not hold true, because if you simplify this, it will come as 1 divided by 2 by 7 and should be equal to 1 by 2 divided by 7. Now I'm converting them into multiplication, so 1 into 7 by 2 should be equal to 1 by 2 into 1 by 7. And if you see that, it comes 7 by 2 and RHS is 1 by 14, and it is clearly not same. Hence we can say that this term does not follow, the whole number does not follow the associative property for division. So it is not holding true. I hope you understood, students. So we have to take different cases for each numbers to verify our answer. Okay, I'll rub this off so that we can do integers here. Let's check for integers now. What we have assumed integers as -1, 2 and 4. So -1, 2 and 4. Let's do addition first. So -1 plus 2 plus 4 should be equal to -1 plus 2 plus 4. And if you see that -1 plus 2 plus 4 is 6, that should be equal to -1 plus 2 is +1 plus 4. So -1 plus 6 is 5, and 1 plus 4 is also 5. So hence you clearly see that integers follow the associative property for addition. Now subtraction. So -1 minus 2 minus 4 should be equal to -1 minus 2 whole minus 4. So LHS -1 minus of 2 minus 4 is -2 should be equal to -1 minus 2 is -3 minus 4. So minus of -2 is +2 should be equal to, I opening the bracket, -3 minus 4. So -1 plus 2 is +1, and this is -7. So hence they are clearly not the same. So therefore subtraction does not follow the associative property even for integers. Multiplication, as students you can clearly see, like other numbers, it will also follow the associative property. So -1 into 2 into 4 should be equal to -1 into 2 into 4. So -1 into 2 into 4 is 8, and -1 into 2 is -2 into 4. So -1 into 8 is -8, and -2 into 4 is also -8. So you can see that clearly it follows the associative property. So multiplication follows associative property for integers. For division, -1 divided by 2 divided by 4 should be equal to -1 divided by 2 whole divided by 4. Let's simplify this. So -1 divided by 2 divided by 4 is 2 by 4 should be equal to -1 by 2 into, this is divided by 4. So -1 into 4 by 2 should be equal to -1 by 2 into 1 by 4. And clearly you see that, students, they are not same. On LHS you have -2 as answer, and on RHS you have -1 by 8, and they are clearly not same. So we can say that division of integers does not follow the associative property. Let us take rational numbers now. So what we have assumed 1 by 2, 1 by 3 and 1 by 5. So 1 by 2, 1 by 3 and 1 by 5. Since we don't have sufficient space here, let us do on a new page. So 1 by 2, 1 by 3 and 1 by 5. Let us perform first addition. So 1 by 2 plus 1 by 3 plus 1 by 5 should be equal to 1 by 2 plus 1 by 3 whole plus 1 by 5. Let's do it one by one. So 1 by 2 plus the LCM is 15, and you'll get the answer as 8 by 15 should be equal to, here the LCM is 6, so you'll get the answer as 5 by 6. 5 by 6 plus 1 by 5. Let us simplify further. So LHS, you get the LCM as 30. Okay, so numerator is 15 plus 16. On RHS the LCM is again 30, and the numerator is 25 plus 6. So LHS, you get 15 plus 16 is 31 by 30, and 25 plus 6 by 30 is again 31 by 30. So you see that clearly that yes, for addition the rational number follow the associative property. So let's do subtraction now. So 1 by 2 minus 1 by 3 minus 1 by 5 should be equal to 1 by 2 minus 1 by 3 whole minus 1 by 5. So again simplifying them, the LCM is 15, so the numerator will be 5 minus 3, and here the LCM is 6, so numerator will be 3 minus 2 minus 1 by 5. Simplifying further, we get 1 by 2 minus 2 by 15, and here on RHS I get 1 by 6 minus 1 by 5. Taking LCM on LHS, I get 30 LCM, and I get 15 minus 4. On RHS I get 30 as LCM, and I get 5 minus 6. So LHS I get 11 by 30, while on RHS I get minus 1 by 30. So it clearly shows that yes, it does not follow the associative property. So rational numbers, while subtraction does not follow the associative property. Now let's check for multiplication and division quickly. So for multiplication, the same number 1 by 2 into 1 by 3 into 1 by 5 should be equal to 1 by 2 into 1 by 3 whole into 1 by 5. If you simplify this, it will be 1 by 2 into 1 by 15. This should be equal to 1 by 6 into 1 by 5. So LHS is 1 by 2 into 1 by 15 is 1 by 30, while RHS is 1 by 6 into 1 by 5 is 1 by 30. So hence, yes, it satisfies the associative property for multiplication. Let's do for division now. So 1 by 2 divide by 1 by 3 divide by 1 by 5 should be equal to 1 by 2 divide by 1 by 3 whole divide by 1 by 5. So 1 by 2 divide by 1 by 3 divide by 1 by 5 I can write as 1 by 3 into 5 by 1. This should be equal to 1 by 2 into 3 by 1 divide by 1 by 5. I'm just changing the division to multiplication by taking inverse. So now 1 by 2 divide by 5 by 3 should be equal to 3 by 2 divide by 1 by 5. I'll again take the inverse. So 1 by 2 into 3 by 5 should be equal to 3 by 2 into 5 by 1. So on LHS I'll get 3 by 10, and on RHS I'll get 15 by 2. And you can clearly see that they are not equal. Hence we can say that rational number does not follow the associative property for division. Now let us summarize what we have learned about associative property. Hence we have seen that natural number follow the associative property while addition and multiplication, but it does not follow the associative property while subtraction and division. Similarly, whole number follow the associative property while addition and multiplication, but does not follow for subtraction and division. The same is the case with integer. It follows the associative property for addition and multiplication, but does not follow the associative property for subtraction and division. Lastly, for rational number also it is the same. It follows the associative property for addition and multiplication, but does not follow the associative property for subtraction and division. Student, it is very interesting to note that associative property is always followed by all the numbers while addition. So for addition, all the number system follow the associative property. Similarly for multiplication. So while multiplication and addition, associative property is always followed by all the numbers. And for subtraction and division, associative property is never followed. So none of the number system follow the associative property while subtraction and division. Students, now let us go to the next topic, which are the important terms such as additive identities, additive inverse, multiplicative identity, and multiplicative inverse. Let us see one by one each one of them. Now, additive identity. By definition, it means a number which when added to any number gives the same number. For example, let us take n as any number, and a is our additive identity. So by definition it says that if a is added to the number n, the result will be n itself. There won't be any change in n. For example, if let's say the number is 5, so what should be added to 5 so that the result is also 5? So it is very simple to answer here that a has to be 0. Hence, in all the cases, the additive identity will always be 0. We can take n as any number from any number system. Let's take n as 2 by 3. So 2 by 3 plus a should give me 2 by 3. So a has to be again 0. So for any number, positive or negative or whatever number you may take, if this condition holds true, then a has to be 0 only. Let's see now what is additive inverse. Additive inverse by definition, it means that any number which when added to the given number, the result is always 0. For example, like before, let us take n as 5. So what should be added to 5 so that the answer is 0? So if you simplify this simple equation, you will get b as minus 5. So it's very simple that the b is nothing but the additive inverse of the 5, so that when you add them up, the result is always 0. For example, let's take 2 by 3 as the number n. So 2 by 3 plus b should be equal to 0. So therefore, b has to be minus 2 by 3. So therefore, it is very simple to understand that additive inverse of any number is always negative of that number. So additive inverse of any number n is minus n, like we have seen here. So additive inverse of 5 is minus 5, additive inverse of 2 by 3 is minus 2 by 3. So let us see now multiplicative identity. So multiplicative identity by definition means a number which when multiplied to the given number gives the same number. For example, if 5 is the number, so if 5 is multiplied by the multiplicative identity p, the answer is also 5. So what could be the number of p it is very simple to answer that P has to be 1. If this condition holds true, then P is always 1. Similarly, if you take any rational number like 2 by 3, so 2 by 3 into P should be equal to 2 by 3. Then P is multiplicative identity and P has to be equal to 1. So once again, multiplicative identity of any number is always 1, because by definition multiplicative identity is the number which when multiplied to the number always give the same number. Let us see now multiplicative inverse. So multiplicative inverse, by definition it says any number which when multiplied to the given number the result is always 1. It's very interesting to find out what will be this number. So let's take, if 5 is the number, if it is multiplied by Q, the answer has to be 1. So this implies that Q will be equal to 1 by 5. So it is very interesting to know that Q is nothing but the inverse of the number 5, 1 by 5. Let's take a rational number. So 2 by 3 multiplied by Q should be equal to 1. So Q will be equal to, in this case you will simplify, you will get it 3 by 2. So if you compare and check, the 3 by 2 is nothing but inverse of 2 by 3. Hence multiplicative inverse, which is Q, of any number n is nothing but 1 by n. I hope students you got the in-depth understanding of all these terms. These terms are very important and frequently asked in exams. If you like this video, please give a thumbs up and share it among your friends. If you wish to see the similar videos in future, please don't forget to subscribe the channel and press the bell icon. Thank you.